High above us, in the vast cold of space, exists a world born from mystery. One that orbits not one, but two stars. It's a real-life version of Tatooine from Star Wars. But what's most incredible is that it shouldn't even be there at all. This is Kepler-16b, a planet that stunned the scientific community when it was discovered orbiting a double star system in 2011. Unlike Earth, which circles a single star, Kepler-16b's journey takes it through a cosmic dance between two suns locked in orbital motion. Binary star systems are common. Nearly half of all stars are part of one. But planets that survive inside them? Much rarer. For decades, astronomers believed that stable orbits in such systems were impossible. Gravitational forces tug planets in chaotic, destructive directions. So when Kepler-16b was confirmed using data from NASA's Kepler Space Telescope, the world of astrophysics tilted slightly off balance. How does a planet like this form? How does it survive the gravitational chaos of two dancing stars? Let's unravel the mystery. First, some basics. Kepler-16b is about the size of Saturn, made mostly of gas, and it lies 200 light-years from Earth. Each of its two suns, one slightly smaller than ours, the other even dimmer, orbit each other every 41 days. Kepler-16b, meanwhile, loops both stars every 229 days, far enough to stay stable, yet close enough to feel both suns' light. But here's the riddle. How could gas and dust come together to form a planet in a region whipped by twin gravity wells? Normally, that kind of gravitational turbulence tears particles apart, scattering them too widely for anything like a planet to ever form. Yet somehow, Kepler-16b exists, serene, stable, and spherical. A silent witness to the impossible. It wasn't just a fluke. Since Kepler-16b, more circumbinary planets have been found. These systems may not be rare, just hard to see. These planets are called circumbinary, orbiting around both stars, rather than just one. Their existence challenges how we define planetary nurseries. For a planet to survive, its orbit must tread a razor-thin line. Too close. Chaos. Too far. Ejection into space. So, how did Kepler-16b find that balance? Scientists believe it may have migrated inward after forming farther away. Out beyond the most violent regions, particles had time to settle, coalescing into planets that then drifted closer over time. It's cosmic choreography. And Kepler-16b is a master of balance. Each orbit a testament to forces perfectly aligned. Oddest of all? From its surface, if it were solid, you'd see double sunsets and shadows cast in two directions. And though it's a gas giant and not hospitable to life, its moons, if they exist, could harbor the impossible. In science fiction, twin suns are an old dream. Yet now they are real, waiting patiently in the dark to be found. New telescopes are enhancing our vision. With each discovery, we rewrite what we thought we knew about how worlds take shape. Kepler was our first pioneer, but missions like TESS and JWST are continuing the search with sharper eyes and deeper reach. Each circumbinary planet tells a story of survival, of motion, of gravity overcome. In them, physics meets poetry. Theorists are fascinated, rethinking models of planet formation under complex gravitational conditions once thought lethal to young worlds. Does Kepler-16b suggest that life-bearing worlds could also form in these places? Could twin suns light up alien oceans? The stability window is tiny, but within it, Earth-like conditions might arise. Somewhere, another version of home could be hiding. And if such a world exists, it may not just be habitable. It might be already inhabited, shaped by light and motion. Even now, hundreds of light-years away, Kepler-16b continues its sweep, silent, beautiful, and still somehow defying the odds. Its journey isn't just celestial, it's philosophical. What other things have we ruled out that are simply waiting to be observed? Every time we find a planet like Kepler 16b, it rewrites one more paragraph of the cosmic rulebook we thought we understood. Binary stars were once thought too unstable for life. Now, because of one quiet planet, they're hopeful places again. We call them impossible planets, but they are real. Kepler 16b is just the first to step out from the shadows.